Hello, welcome to the RC Wallet Vacuum channel. Well, today's going to be part 2 of the 5th scale engine dyno build, and I'm just going to go over some of the fabrication and some of the mechanical setup on it. I originally wanted to film some of the fabrication, but it takes a lot of time and time's not on my side right now. So let's take a look at what's already been built. So over here is the operator station. There's going to be a piece of plywood down here, and the keyboard and the mouse are going to be located here. Obviously got the monitor. I was going to put this on a full swivel, but I ended up at the last second just setting it so it spins on the horizontal axis. So if you're sitting right here, you can just lean it right down, good to go. I did manage to get lucky and get clearance on the, it wasn't luck, but got clearance on it anyhow, the tank fill. So this is the strain gauge or load cell I'm going to be using. And I still got to make the torque arm to come off here. I'm doing foot-pounds, so I got to make a foot-long torque arm to come over and catch that. There will be a guard here to keep from getting your hands slammed into that. I originally planned on putting a guard here too, but I'm not sure if the pipe's going to need to come through there from time to time on some of the drag pipes. So I'll have to work that out later on. And then somewhere along here is going to be the throttle control pot. And once I get engine situated more, I'm going to be putting a post here and for the servo mount. I'll get more into that on that side of it. That's pretty much it. Oh no, actually, and this is the flow control I'm going to be used for controlling the pressure. It's just a manual control. And I may someday automate this thing with a stepper motor, but for now I'm just leaving it manual. And there's going to be a gauge on there so you can read your pressures. I'm anticipating probably the biggest problem I'm going to have mechanically is getting the hydraulic lines down into the pump situated in such a way that it doesn't cause a counteraction on the torque of the motor. When this thing fires up, I'm going to have a tear routine in the software that'll actually tear out any pressure that's already sitting on the strain gauge from, if it's from the last run or if it gets repositioned or something like that. So hopefully that'll take care of that. There will be more like in the software, I'll have a calibration schedule put in there too. It shouldn't, once the initial value is determined, it should be pretty close, not have to be changed. I mean, if you get, it might be an issue seasonal if you get a big temperature change. These strain gauges are sensitive to temperature, so we'll deal with that in the future. So let's take a look on the other side. So over here we have the business end of things. I have a large suction filter that goes in here to feed the inlet of the pump. I still gotta get some adjustable feet in there because the pump does hang down, or the filter does hang down a little bit below there anyhow, which doesn't matter because I had to have clearance for the gear. So, and plus I want to have feet so I can level it out, stabilize it a little bit. Now, as far as the pump goes, that's a 1.18 cubic inch pump. So at 3,200 psi they rated at to and 3,000 RPMs, it should be capable of 14 gallons a minute, which I think that's like 27 horsepower would be required to run that properly if you're using a piece of equipment. So this stand should allow me to test up to 30 horsepower or thereabouts without a problem. And if worse comes to worse, you can always go to a larger displacement pump. I'm putting in some good sized lines and filters and stuff like that, so it could run higher flow rates if need be. And according to the specs and calculations, 500 RPM should give about 2.18 gallons per minute. 1,000 RPM should be 4.61. 1,500, 7.07. 2,000 be 9.42. 2,500 RPM is 11.91, and then 3,000 RPM is 14.44. And I believe this thing is rated max at 3,000 RPM. So when I spec'd out the pump, I wasn't sure exactly how I was laying everything out, so I got a pump that was reversible. And of course, Murphy's Law dictates that it's running the opposite direction I need to go, so I do got to pop that pump apart and swap the gears in there. So that has to be dealt with. Now over here at the motor, I'm gonna add in a somewhere in here a mount for a Losi 5T tank. I have a 5T laying around here, and I'll just use that as my guinea pig to lay it out. And like I said, I'm gonna be putting a post over here for the throttle servo, and then probably have to adjust linkages depending on what kind of engines run in there. And this reservoir here is 5 gallons, by the way. So as far as mounting the engine goes here, it's going to be mounted on this plate, but I don't have the front section. In advance, if you're watching this video, this is what I got with the Zenoa. I just need the clutch bell thing there, and then a housing, and then the bearing, and some kind of pinion gear. preferably a 19, but whatever you got laying around, and I can complete that, the mount on that. So how this is going to be set up, there's slots on either side here, and there's going to be angle welded to this. So I'll be able to move this hull motor back and forth to mesh up with the ring gear here. Now, Vance and Wade wanted to go like 30,000 RPM, or capable of going up to 30,000 RPM. You got a 3,000 RPM pump. That's a, obviously 10-to-1 ratio. That's a lot of gearing that's got to be done. Can't really do it in one step. So I came up with the idea of might as well simplify. It's kind of killing two birds with one stone here. I'll simplify how the mount of the engine. So the engine's mounted exactly how it would be in the vehicle. All assembled with the actual pinion gearing you want in there. And then at the same time, I'm getting the first stage of gear reduction right here at this section. And then from here down in will be the final stage of gear reduction. I think this is like around three or so, and there's one 6 or 7 down here. I forget the exact numbers. Right now I got a 58 tooth. This is off a Losi 5T 1.0. This I'm going to be making a hub that goes onto there, and then it's going to key into this shaft, and that'll allow to be able to easily pull this gear off and swap to a 62 tooth or whatever you want to put on there, and it's just keyed in there. So I will, in a future video, I'll probably do some. I got to do some old-fashioned broaching keyways in this. I might do a video on that. At the same time, I also got to broach a chunk of plastic on here. Probably stick it right in here, rotary piece with a magnet in there, and a Hall effect sensor will sit here. That's going to be detecting the RPM right there. This is the gear that's going to go here. I got to bore that out because I couldn't find a metric one. This is a 10mm shaft I got here, and I got these 10mm pillow blocks set in here. And then once I get to clutch parts and know the exact specs on here, bore out this, or drill the holes for the mount the motor to this, and then I got to notch this plate to clear the gear so I can slide it all the way over. But like I said, this will be able to slide back and forth to match pinion and ring gears, different size when you run different size gears. And then if any adjustment needs to go this way, this will be able to slide back and forth. It's just going to be on a shaft with a keyway and a set screw. So down here at the driven shaft, this is a 60 tooth. I'm using number 35 chain. I was having a tough time finding that big of a sprocket with that small of a bore. It's 5/8 shaft. I just thought about actually trying some different mini bike sprockets and making a hub to mount, but I was able to find a 62. That should get the gearing down in a very safe range. And I'm only using just some self-adjusting pillow block bearings. These bearings up here, I think they're rated for 34 or 35,000 RPM. Down there, those are 4,000, but it should be kept well below that. And then back there, I just got a 5/8 solid rigid motor coupler to solidly attach to that pump. And then, like I said, there's going to be a torque arm coming off the front of that pump and laying down here over on that torque arm. So that's about the gist of it for this part of the video. One other thing too is I've rethought I'm going to do the electrical on it, and I believe instead of putting any AC connections, I'm going to have it run off of two paralleled up 5S's, and I think that should work pretty well. Make it nice and portable, and I don't have to deal with all the EMI issues with AC. But so the plan for this is to go to SRE Custom. So if you're into the engines and two-stroke stuff, go check out Wade and Vance at SRE Customs. And I think Vance has his own channel at SRE Customs and Fifth Scale Ripper, I believe. Go check that out. And the plan is I may do a little broaching video next time, but probably the next video will end up being a final assembly, and putting electronics in there and doing some debugging. So in the meantime, thanks for watching.